why don't you hand out after class, okay?
Okay.
After class. So we are doing, first thing we did in the beginning of the semester, we did ER modeling. So it's a conceptual modeling from the information. We'd like to make some organized information that is using the ER modeling. That's called the conceptual modeling. Through the conceptual modeling, we can organize some information. However, it's far from our database structure. So to keep the information, organize the information in our database system, we are going to use the relational database model. So we define the relation. Relation is a group of data. Each data has a number of attributes. So all the record in the relation should have the same the set of attributes. Also that's why with the several conditions, the constraint, the key constraint, the entity integrity constraint, and the referential integrity constraint. Sometimes you have your own the constraint, so that can be implemented by sometimes the trigger, the assertion, and other the functionality that provided by the database management system. So using, for example, using the Oracle, so we can actually implement the user-defined constraint as the check constraint. Also, we will learn how to use the trigger for the user-defined constraint later during our exercise like that. So we have the ER modeling, and also we have the relational database model. So after we complete the ER modeling, we need to build a relational database model. So there's a gap. So in this chapter 9, we are going to map the ER model to the relational model. So it's using the step by step. So we have discussed from the step 1 through step 6. Okay. So today we are going to see the remainder of the mapping. It's just straightforward. It's just using the step by step. For example, for the regular entity means the entity that has the key attribute. Okay. In this case, we can auto-convert the regular entity. It's for relation in relational model. Eventually, it will be table. Okay? And also, we should have the attribute. From the attribute of the entity, we can create the attribute of the relation, attribute of the table. Then we can select one of the key attributes as a primary key. Then underbar. That is the first step. The second step, the main difference is weak entity does not have the full key attribute. So we need to use the identifying relationship. From the identifying the relation, we can borrow the key attribute from the identifying the entity. Then we can make the relation. In other words, a table. And also we need to create a foreign key to represent the identified relationship. In the step 3, 4, and 5, it is the relationship in ER model. There are 3 cardinalities of the relationship: one-to-one, one-to-many, many-to-many. So in case of one-to-one, there are 3 different ways. One is we can merge two the entity. Why? Because it's one-to-one. One-to-one means it's the same thing, right? So we can merge it into one. The second option is we can create the in-between table, okay? In-between relationship that represent the one-to-one mapping only. Then create the 2 foreign keys. The last option is we can just create the foreign key, okay? At that time, the one-to-one, any attribute associated with the one-to-one mapping, any attribute in the one-to-one mapping can be either left-hand side or right-hand side. You need to decide the appropriate of the proper entity that can include the attribute of the one-to-one relationship. Then we can create the foreign key. So it depends on the situation. It depends on your decision. It depends on the application analysis. Which one will be selected? One-to-many relationship is quite simple. We can create just a foreign key. Then many-to-many relationship is a frequently happen as you have seen in your the project A. So in case of many-to-many, we need to create the table additional relation table. Then we can create the two foreign keys. Then in step 6, like the locations of the department. Location actually is defined as a model as the attribute of the department entity, but according to the definition of the relational model. Relational model only allow atomic value, single value, not the list, not the array, not the multi-value one. So because of that, we need to create the additional relation or additional table for the multi-valued attribute, then create the proper primary key as well as the foreign key. That is up to step 6. So we can have mostly like this one. Okay? So except the n-array relation. N-array relationship means so there in one relationship there are 3 or more the table entities are the relative. Okay? And also the enhanced or extended ER model. So we will discuss the rest of the step that we missed the last week. Okay? So from this, the ER model, this is for the company database. From the ER model, you should be able to create the relational schema diagram. This is called the relational schema diagram that includes the entity, the relation, okay, relation name, and its attribute, and also primary key. This is called the primary key, should be underlined, and also you should have create the proper foreign key. At that time, be careful referencing and reference. There is a direction, it's a directed, the constraint. Okay, any questions so far? Which means you should be able to convert it. Okay. So in the homework, so there is a homework to practice such a mapping. Okay. So let's move to the step 7. In case of an n-array relationship, we have already seen in case of such an ternary relationship, this is not directly addressed. So we can convert. We can actually change such an array relationship with the additional can be one option. After you change it into this one, then you can map. So this is the what? Just one-to-many. This is a one-to-many. This is a one-to-many. You can. Then this is another table. You can do that. So similarly, you can create the additional table like the supply. Okay, supply the ternary relationship map to the relation table. Okay, that is a supply. And if that one is the attribute like the quantity will be attribute. Then what is the primary key of this one? Primary key, because this is the one-to-many relation, one-to-many relationship, one-to-many relationship. So you should create the one-to-many foreign key, one-to-many foreign key, one-to-many foreign key. Actually, many to one. Okay. So reference. The side is the one. Okay, should be unique, and this is a many side. Okay. So you should have a S name, project name, and part number as a key to identify how many or that. Okay. So you can create, you can convert into the one, the ternary relationship with by adding additional the entity and 3 binary relationship. Okay, one-to-many relationship that you can convert into this. So you can address the problem of the ternary relationship. Okay. So this is the summary of our mapping. So in your project, you should be able to convert the ER model to the relational schema diagram. So the remainder is the extended part or enhanced part. So what is the enhanced or the extended ER model is a super subclasses relationship like this one, employee, we have the employee, that this one has secretary and the technician and engineer, okay, like that. So this is, for example, disjoint, either disjoint or overlap. Overlap allow the multiple, the membership of the subclasses. And either single line or double line. Single line means it's an optional, which means that there exists the employee who does not belong to any of the subclasses. The double line means it's a full participation, okay, mandatory participation, which means it should be at least one of these. In case of overlap, one at least, and in case of disjoint, it should be one of these. This is the super and subclasses relationship. Don't forget how many entities? It's just one entity. Okay, don't forget that. Using this idea, there are 4 different options when you convert into the relational schema diagram. In other words, when you create a table, there are 4 different options. First option is option 1. One relation per entity. One relation per entity, which means in that case, how many? So let's see the example of this one. We are going to use this example for practice. Option 1. So it's not entity, class. Because we have only one entity per class. One relation per class. How many classes we have here? 4. 1, 2, 3, 4. 1 superclass, 3 subclasses. So we have 4 classes. So which means we are going to create 4 relations. One is for employee. What is the key attribute? SSN. And what as name, birthday, and address. Okay, then next, secretary. We create a secretary. So, what should be the primary key of secretary? It's SSN, because as we have discussed last time, it's inherit all the property of the superclass to the each subclass. So which means it's an SSN. Do I need to write down all of this? We don't have to. Instead, we can create a foreign key. Then we can find such an information, right? We don't want to put the same data over here. Why? It's a redundant information. In case of redundant information, 2 problems. One is waste of your space. It's the same data, but you keep the 2 times, so which means waste of space. Second, hard to manage consistency. What if the address is changed? You need to inform all the table. You need to inform to all the department. When you move to the new house, you need to inform to department, you need to inform to the HR, you need to inform to the career service, you need to inform to the ISS. Do you want to do that? No, nobody wants to do that. In case you need to inform, sometimes you miss, then your data is not consistent. So because of that, we can create the foreign key. Then only secretary information is the typing speed. Same thing for the technician. What is the key of the technician? SSN. Then it's a primary key and it's a T grade. And same thing, and the engineer, SSN, and it's the engineer time. Foreign key. Foreign key. This is the first option you can select. Okay? So one relation per class. It's just simple. And what about the second option? Second option is we are going to focus on only subclasses. Okay? So which means we will create the relation per subclasses. Each subclass. So which means we have, the first one is a secretary. What is the primary key of secretary? It's a SSN. Then secretary has a typing speed. That's it? Not yet, because we need to keep this employee information, because we are not going to create a table for employee. Okay? Instead, secretary, technician, engineer only. So we need to inherit name, the birthday, address, and job time. Okay. And next, technician. Same thing, SSN, T grade, name, birthday, address, job time. And what about engineer? It's the same thing. SSN, engineer time, same thing. Okay? So this is the second option. What is the main difference?
No relationship.
This one has the employee superclass information separately. This one, no. So what is the main? So how do I select either option 1 and option 2? It depends on your application analysis. For example, if your application access secretary separately, and technician separately, and engineer separate, there are 3 main applications in your system. One is only for engineer, one is only for secretary, one is only for the technician. It's a separate. At that time, this one is better. However, in your application, in your system, you have a lot of applications that access only employee information. Like for example, we have the birthday, who has the birthday this week. Okay, if you use this one, you need to access separately to a table. But this one only access this. If you have any common information, this one is better. Also, in case of overlap, which one is better? This one or this one? This? Definitely this. Why? Because you need to keep the 2 times or 3 times of the same table. Because you cannot create the foreign key here. They are not super and subclass relationship. Okay? So you guys need to decide which one is a better option depending on the requirement. Okay? Application analysis. Okay, the next. Anyway, how many entity here? It's 1 entity. Usually 1 entity represents 1 table, 1 relation. So option 3 is create 1 relation only. Okay? So 1 relation. What is the primary key? SSN. Then name, birthday, address, birthday, DOB, okay, job type. Then, depending on job type, we can have typing speed. If you are secretary, okay, then typing speed. And if you are technician, it's a T grade. If you are engineer, it's an engineer time. That's it. Then, for example, SSN 111, name Lee, okay? It's the January 1st, and address, and job type is we can use the secretary. Typing speed is 100 words per second. Not second, per minute. Okay, 100. What about the T grade? 9. And there's another example, 222, and James, and January 1st, address, and the T grade. So technicians. In this case, null for typing speed, and T grade is the height, and engineer type. The engineer type is a null. So in case the job type is not related, the value will be null. Otherwise, we can put the value. So this is the second option. With the type of what? Subclass. However, the problem of this one is good for this joint, right? What about the overlap? So I'm secretary and technician. Job type, according to the definition, requirement of the relational model, only one value. So there is no way to represent multi-value, the subclasses. So this is not good for overlap case. How to address that one? There is another option for, this is 3. So one relation. Okay, so same thing, one relation. SSN, name, birth date, address. Then instead of job type, we are going to ask whether you belongs to secretary or not. So secretary, yes or no, using Boolean type. Boolean, yes or no, true or false. Okay, then this is the typing speed. Also ask technician, yes or no. Then T grade. Engineer, yes or no, engineer type. For example, 111, 111, 111, lead, and January 1st, address, secretary, true, or yes. Okay, typing speed, 100 words per minute. And technician, yes, true, or yes, and high. Engineer, no, false, or no, and null data. In case it's not related, not type of the superclass, then it will be null data with the false. So in this case, we can represent both overlap and disjoint. However, what if you have more? The types, like the 100 different job types. You may have 200 columns, 200 attributes. One is for type. In case you have the additional, it will be much bigger, but most of them will be null value. What does that mean, null? What does null mean? Nothing. Okay? Even though that's nothing, is there any way represent nothing without space? No. You need to make the data structure to represent NULF. It's a waste of your space. Even though it's nothing, the semantic meaning your perception is nothing for the null. But computer need to use space. Okay, so waste of your space also. Okay, so this one, it's okay to represent the overlap, but you need to think about how much the space, the performance. Okay, so there are 4 options how to select depending on the situation. But for example, if you application access mostly through the employee, okay, not very specialized for the secretary, technician, and engineer. Okay, at the time, option either 3 or 4 are better than that one. Okay. In case you have the access separately, but also you have very strong data consistency, this one is better. Okay? And also, if you have the overlap data, this one may not be possible. You need to select either this one or this one can address all the cases, but it's required 3 the foreign key. So you need to think about the management issue and performance issue also. Okay, so let's see the example more for this. Car and truck. Okay. So in this case, so we have the vehicle, one superclass and two subclasses. It doesn't matter the disjoint or overlap in this case. But in this case, if we are going to use the second option, it will be car and truck. Okay. What if the first option should be, you need to create the vehicle, you need to create the car, you need to create the truck relation. Then what is the key is a vehicle ID. Vehicle ID. So you need to make a two foreign key such a way. Okay? So option 3 and 4, option 3, you can create one relation for entire entity, including super and subclasses. Then using the job type of subclass, you can add as many attributes as possible. If not, the related associated to the job, it will be done. Otherwise, you can give the value. Okay? This is if we are using the last option, first option for the part is we have one superclass, two subclasses, okay, at the time. So if we create the relation with the last option, so we have the M flag and P flag, yes or no. It doesn't matter the name of, but the type is yes or no, or true or false. Then this related to this related to this one, okay. What about the multiple inheritance? Okay. So this is a person. We have the three subclasses, and from the three subclasses, we have the employee has also three subclasses of this one, and the student has two subclasses. Even the student assistant is a multiple inheritance. We need to consider both of them. Okay. And student, it has also two subclasses. Overall, how many? How many entities? It's one entity. Okay. But when you apply the option 1, 2, 3, 4, should be 4 each. 1 super subclasses group, 2 super subclasses group, 3 super subclasses, 4, 5, 6. You can apply separately. For this, you can select one of 4 options. Among 4 different options, you need to select one of them. Okay? And this one, you need to select one of them. This one, you need to select one of them. This one, you need to select one of them. For each super subclasses, you can select one of the options. Then, if we try to convert this one to the relational model, this is one of the examples. Okay, let's take a look at. I'm going to back and forth. For this, person, employee, alumnus, student, what options? Which option is selected?
Can you go back?
So this one, person, employee, alumnus, student. Okay, only focus on this group. Okay, then this is our answer. Which option is selected?
The first one, because it's overlapping.
It's the first option. 1. Person, employee, alumnus, student. 1 per each. 1 relation per class, each class. Okay? So then we create, that's the reason you create the foreign key. As you can see, only first option has foreign key. The other we don't have. Okay? Then, what about the employee, staff, faculty, student, assistant? Employee, staff, faculty, student, assistant. Which option is selected? You can focus on employee. Which option?
Either 3 or
Either 3 or 4.
Four.
Right?
Four.
Which one? 3 or 4?
4.
What is this? Employee time. Either staff, faculty, student, assistant. Employee time. Time is third option. What about this one? You can see RA, research assistant 1, RA flag. Teaching assistant 1, TA flag. That is RA or TA. Please select last option. Get it? So in this is a very extreme case. Okay, you may not see such a case, but if you can understand that this one, so you understand all these 4 options. So RA flag, TA flag is created by converting the student assistantship to this one. What about this? Student and student assistant. Well, first, why don't we take a look at student part? Student has the 2. Graduate student, undergraduate student. Student has the graduate, undergraduate. Which option is selected? It's the last option, 4th option. Whether graduate 1, undergraduate 1. And what about this one? Student assistant. This is also super subclass. Last option. Yes, 1. Unfortunately, there's no specific. It's a percent time. Yes, there's a percent time. So should be.
Should go at the end, right?
Yeah, I think the percent time should be added here. So this, the attribute is not added. It's a mistake. Okay, then what about this one? This is actually we have the 2. No? Yes. 1 entity, but this is a multi-value. Multi-value, how can we convert the multi-value? Create additional relation, then foreign key. So additional, it should be connected. It's a 1 primary key, then create the foreign key. Okay. So this is the extreme case, but in case you have the multi-level super and subclasses relationship, you need to apply the separately, each of them. So it depends on the situation. Okay? It depends. Any question? The remainder, we have union type. Okay? Do you remember that union type is a subclass and we have the superclass. So multiple entity, multiple superclass and inherit to 1. So you represent the union type. It's kind of category, type of owner. Okay? Then can we select any of this? The problem is there primary key.